and thank you for joining us in today's webinar on discussing Let's Discuss Mechanical Integrity. My name is Sonali Garg. I'm a chemical engineer with over 4 years of experience working in the oil and gas domain. And here at AsInt, I'm a solution engineer and part of the business development team. So let me quickly take you over to the topics for today. So first, we are going to start with what is mechanical integrity? What is the importance of it in asset-intensive industry like ours? And what is the evolution that we have seen in the industry standards and codes? And our speaker, Tanmay, is going to take us through it. Then we are going to move on to the major challenges and the best practices that we have learned over the years. And our expert, Paul, is going to talk about it. And finally, we are going to move on to what SAP and AsInt have together accomplished in this space. And for that, we have a guest speaker, Tiago Fernandes from SAP to represent us. And we move on to the system demo, where we are going to see everything in action and end with the Q&A session. So without further ado, I'll just pass on the stage to our first speaker for today, that is Tanmay. Tanmay, over to you.
Hi, everybody. Thanks for joining from AsInt side and SAP side. Thank you so much. So let's go through, we are talking mechanical integrity today. So it's very important to realize why we are doing it, right? Like mechanical integrity, we know all over the world, in the North America, Europe, Asia, and Australia, all of the sections, we have mechanical integrity as a really big industry now. And we need to just get and see how the roots of the industry came along and then why we do it, right? Why are we doing what we are doing it? What drives us? What wakes us up every morning to do this, right? So just a little bit of history background that a lot of people might be aware of is like back in the 19th century, there were a handful of places in the world that started like getting crude oil from the ground, right? Which is like, I know there's instances in Poland, there was instances in UK, instances in US, China. So there were a lot of places in the world that were making business out of the crude oil. And then eventually, we all know the Standard Oil history, right? Where Rockefeller kind of formed the large conglomerate of the oil and gas industry. Back in the late 19th century and early 20th century. And then it became a big conglomerate of oil and gas giant. And then oil and gas became like this big corporate industry that people started consolidating assets and stuff. Now, with that, a lot of like earlier in the days, a lot of safety incidents start occurring, right? And then you start realizing that human safety is important when these operations are hazardous. And then API comes along, and the first real it was formed in very early, like 1910s, I believe, and then in API 510 was released in 1958 that covered the pressure vessels inspection code that we still have in place with several revisions. After that, you see there's a little bit of gap between when these new codes were developed. But then 1984 was a large disaster that a lot of us know about. It is the Bhopal gas tragedy that kind of reignited the fire per se for safety needs. And then, so when we say why we do mechanical integrity, I'll say the first and foremost thing that sits on top of everything is safety of our people, right? These plants that we operate, the work environment that we operate in has highly hazardous or flammable chemicals flowing around. And if you don't take care of your mechanical integrity, that kind of is like creates a lot of hazards for not just people working in the plant, but also across the population. We know like blast radiuses and stuff, right? In mechanical integrity, when you calculate, it could be several miles from the plant as well. So I believe the first and foremost thing that drives all of us is safety of our own people working around us and the population. And then several codes came along because of the pressure from and all the initiatives from OSHA and API and ASME and ASTM standards and stuff coming along. And then API 570, 653 for Tang, those came along. And then the second piece is a lot of mechanical integrity departments are now getting more advanced And one of the largest advancements that happened was the risk-based inspection, which is our API 580 and 581 codes that came along in the early 2000s, right? So second piece of why we do this is we are all given a task to strategically maintain our assets by not overspending, because with regulations and codes comes along cost inflation. And then from early 2000s, what happens is, yes, we need to keep everything safe, but also all of these are corporate businesses that need to make profits. So we all need to stay strategic about how we go about managing our assets, right? So along with the safety, we then changed over a little bit to optimization as well. And then also API 581 does not undermine safety by all means at all, right? Because it takes you to more high consequence and highly risky assets, which could not have been identified if you were on fixed time. So then uh, all of our standards focused on two things, which is safety first, and then how can you optimize your operations for achieving the same level or better level of safety. Uh, Now let's talk about the whole asset integrity lifecycle real quick, Sonali. So the full life cycle, the way we see it is, first you create your asset strategy, right? And those could depend on, a lot of people are still on the 510, 570, and 653 fixed time cycles. And a handful of our customers are also on, and all across the world, people are following risk-based methodology, where you can drive your strategy based on 580, 581, and then there's other complementary stuff as well, such as IOW, CMD, and CD corrosion control documents as well. Once you have your strategy, you go to your inspection plan based on your strategy, which provides the method of inspection, the coverage you need to get from that inspection, and your target date for inspection, right? So it could be, these are outputs from an RBI study or outputs from 510, 570 area that prescribe pretty much in a lot of detail on what exactly you need to do when you go out and do an inspection. And then once your inspection plan is made, you go out in the field and execute the inspection where you collect all the data, right? Now, all the data collection ideally must be in digital format in today's world, but we all know that it's not. And along with that, there's also a traceability of like, where was the data you collected. You need to also have like, it was the personnel that collected it had the proper competence to collect it, or were the calibration records for the UT meters and several other equipments that you collected the data, right? So that can give you an overall picture. I think the pieces second and third, that the traceability and competence piece are like not combined together with the data collection for now. But that's how we see. We see like data collection just doesn't mean collecting a CML data or collecting a checklist, but we also have to trace the other pieces that actually add to the legibility or the uh, rawness of the data. And then the last piece is, okay, now you have data. Now let's evaluate, right? So our like compliance to standard, we can do fitness for service if needed based on the data. We can raise any non-conformance and repairs requests and replacements or upgrades decisions if the data tells us. And then using all of these, we update our strategies again. So that's how we see the full asset integrity life cycle. And then with the life cycle comes challenges, right? So now we are going to hand it over to Paul, so he can discuss, okay, here's the life cycle, but what are the challenges that are currently our customers and a lot of other people are facing in the industry?
Thank you, Tanmay. So, Paul, quickly, before we move on to the next segment, I think this will be a good time where we can connect with the audience once again and have a quick poll. So, on your screen, you will be able to see we would just love to hear what are some of the bottlenecks, some of the biggest challenges that you, in your respective roles or your organization, you have seen face in while we are trying to maintain the mechanical integrity. So, if you could just take a few minutes to chime in your responses on that, we'll greatly appreciate that. Quite a lot of responses that we receive, and I think as we move forward, I'll let Paul and Tiago first introduce themselves and discuss some of the case studies and the customer challenges that they have encountered so far in their career. So the stage is all yours, Paul.
Yeah, excellent. Thanks a lot. Thanks everybody for joining us today. My name's Paul Raithby. I'm a consulting project manager at AsInt. So I've got around, well, just coming up to 3 decades of experience in maintenance, reliability, and mechanical integrity in the hazardous industries. I started at trade routes and worked through to professional engineer level in reliability and mechanical integrity and inspection, followed by leadership of inspection department, implementation of various codes and standards and improvements within that role. And then I moved on to become an RBI implementation consultant over the last few years. So a good experience in this, these workflows, these processes, these business cycles, along with operating in different parts of the world. So a kind of global experience in this region. So Tanmay just talked about what is essentially a continuous improvement loop, a plan, do, check, act type cycle where we're evergreening our strategy and making sure that what we're seeing in the field is what we're then updating and keeping our asset strategy evergreen so that we can maintain our compliance and maintain our safety and reliability performance. So I'm just going to take you now through a customer challenge here. I've picked one particular customer who's presented a good few challenges for us to solve. So this is a major oil and gas global customer with multiple regions that they operate in, as well as offshore. This customer, it's a very mature customer in terms of their business processes for mechanical integrity. So they have their own risk model, their own mature risk model that doesn't necessarily completely follow industry standards, more of a hybrid approach with using some industry formulae for their risk calculations, as well as their own versions of those. So an interesting problem there, that they don't use necessarily a completely flat standard that is comparable to everybody else. So from an off-the-shelf type product, it's not really fitting their needs. And they also have mature inspection management business processes developed over decades of experience and operation. So yeah, a large client with a great reach. But as we see with many of our clients that we engage with, this client had multiple data silos, multiple sources of the truth. So they have multiple databases for that mechanical integrity life cycle. So they were looking to consolidate those databases to a single source of the truth. So and minimize the number of those silos they have. So we were presented with their business processes, both from an asset strategy point of view, so RBI, risk-based inspection, as well as their inspection processes. Their risk-based inspection strategies or their documentation contained a number and mix of complex calculations, as you'd see in a standard like API 581 Bayesian model type calculations, as well as more simplified logic. So they have a good mix and a hybrid solution for that, or a hybrid set of standards for that, for probability of failure calculation, but also for how they determine the safety, health, and environmental consequences and financial consequences for those failure modes. They were also presenting us with a methodology for how we can define when risk transitions from one level to the next level, say from, let's say, low to medium to high, at which point we would target an inspection to mitigate that risk, or another mitigating action to conduct in the field so that they can maintain their risk at acceptable levels. So from an asset inspection point of view, they did, again, a hybrid approach to how they've developed their own procedures. some compliance with or some alignment with API codes in terms of your API 510 checklist, these kind of typical documentation we would see for capturing data in the field, but not necessarily completely aligned. So customization in that area, and as well as how they manage their defects. So if they have undesirable conditions found within the field, how do they then manage those inspection findings, and how do they also drive those findings and the resolution of those findings to completion, and track that completion, so they can show that line of sight from I found the defect and I've now closed it, and I can see that within my tool. Another process there that they came with was strategy validation. So we talked about how we close that loop in the plan, do, check, act cycle there in the mechanical integrity cycle. But what about long-term continuous improvement? How do we make sure that our strategy models are kept up to date and they're effective for the plant that we're running, and for the failures that we're seeing? So we were able to build a validation process where we can compare the field inspection data with the strategy data in terms of what was predicted and what was actually found, and then we can close that continuous improvement loop to allow the strategy to be redefined to make it sure it stays effective. Corrosion trending, again, we have models. We made some changes there, but to meet their specific needs of how they want to trend corrosion, how they want to group, how they want to deal with CMLs, as well as in terms of HF alky flange monitoring, how we can use non-numeric data to measure condition, to analyze condition, and to trend over time, so that we can keep a good track in what the condition is of those types of inspection challenges there. Some other elements as well is our mobile inspection application, extending that some features there, and we also improved the strategy evergreening. So we have, again, back to that plan, do, check, act cycle. When we come back to evergreen our or reassess our strategy to make sure we are taking into account our new inspection results and our new corrosion rates, that we can do that in the most efficient way and effective way, so we keep that strategy up to date. Okay, so we were able to achieve that through our adaptive risk model processes, as well as our templated approach to asset inspection templates and CMLs. So our ethos, if you like, or one of our key benefits of the application really is our adaptive risk models, and the fact that our adaptive templates, that we don't, as a company, we don't force our models upon our clients. Our clients know their assets, they know they're in mechanical integrity programs, especially mature clients such as the one I've just talked through. They know their assets, they know what they're doing. They don't necessarily want to be pushed down a particular way of working. So our adaptive risk models allow us to take a model, for example, API 581, which is basically an off-the-shelf calculation methodology provide for risk-based inspection. We can take that, but we can also modify that. If you're not happy with particularly a way that a damage factor is calculated, if you're not happy with the output from the strategies in terms of the recommended inspection effectivenesses and how they're developed, we can modify all those and also keep those up to date. Low code or no code within the SAP ecosystem allows us to be able to do that with a minimum amount of effort. So we can provide that continuous improvement and that configurability and customization for not a great deal of effort. Then next slide. So what are we trying to solve with our application within the SAP ecosystem? some of the things that we're delivering there is essentially all about value to our customers. So we talked about data silos, multiple sources of the truth. We have inspections that are kept in paper stores. We have, within the filing cabinet, we have Excel spreadsheets being used for this. We have multiple different databases, one for inspection, one for RBI, one for something else. We're helping to consolidate that into a single source of the truth, single master data, and doing that helps us within the SAP ecosystem to also with that seamless integration within our EAM, our Enterprise Asset Management, and our ERP, Enterprise Resource processes there.
So,
I think,
Paul, I think since we are on the subject of SAP ecosystem, this might be a good time for Tiago to take over and talk about the unique value proposition that SAP has to offer in this space. Tiago, the stage is all yours.
Pass you on to Tiago. It's perfect.
Great. Thanks, Sonali. Thanks, Paul. My name is Tiago Fernandes. I'm part of the SAP team leading on Europe, Middle East, and Africa, the business development for asset and service management. And of course, we are very happy to partner with AsInt because they really bring a value proposition to be integrated in our, I would say, broader best practice to manage the asset management topics. So I start with a question. What is in the, I would say, asset manager or asset management professionals' mind, specifically when they need to address these challenges that was mentioned by Paul? So typically, as an asset manager, I would love to have in one single source of truth, I would say, the basic information around assets. So a financial perspective, where I have all the costs related with the investments that I'm doing on this asset, but also I would say the maintenance costs that I need to address for the future to keep the asset safe and up and running. But also the second perspective, it's about the technical information, okay? How can I manage and understand what is, for instance, a degradation pattern without comparing this information with the design information that comes from the design phase? So all these kind of things, this is normally, I would say, requested, and they are spread by different silos of information, and it's very hard to consolidate to get this financial perspective. And the third one is the operational perspective. It's during the operational phase, I need to understand what is the history, what is the operational context of a particular asset to understand how can I improve his reliability, how many breakdowns he had, if I can address, for instance, a potential failure for the future using the SAP capabilities with the technology part. But this is where we consolidate everything in three pillars in our strategy. First is to deliver to our users the best in class processes where we are closing all the topics around the design to decommissioning or the acquire to decommissioning an asset. Okay, this is supported by a technology layer where we are contextualizing every decision with data, removing all these data silos that normally the organizations had. And the topic around mechanical integrity, it's one of the most important ones, specifically because this is where we look around what is the remaining useful life of particular equipment, a particular pipeline, a particular tank, whatever, and try to address what should be the actions that we need to do to keep these assets safe, reliable, and fitness to be used into the organizations. And then last but not least, and following the SAP mission to improve the people's life, our idea is to connect all these dots in very nice user interfaces, very easy to use. And of course, our idea is to simplify as much as possible to the checking the information available for this particular asset. when we see, and next slide, please, topic around mechanical integrity, this mechanical integrity topic, it's integrated in a broader process that we consider the asset lifecycle closed loop that goes from the design phase and also the asset investment planning phase, where we are addressing the investments, the costs that I need to have for the future, also targeting the topics around the project of that asset, the controlling the technical information, and then the topic around the commissioning phase. Okay. Then there is a second phase that is the commissioning and the asset maintenance strategy, where the topic around risk and criticality analysis, topics around reliability-centered maintenance, RBI, and also failure mode analysis are a very important subject, specifically to define what is the right strategy to maintain a particular asset. Okay, and then on a lower level, we have the asset health monitoring. And once again, all the data that we are capturing from the field on automatic way or also even in a manual way are very relevant, specifically to understand where and when I need to act in terms of maintenance activities, in terms of repairs, and other activities that are related with maintenance. And then last but not least, after I receive all these insights coming from the field, I need to execute. Okay, and the execution, it's of course supported by planning and dispatching tools, and also some capability to execute mobility activities, maintenance activities, inspections activities in the field. And this is where SAP and AsInt are working together exactly to close the loop and have a mechanical integrity topic as also a corporate process for asset management. And with this, I'm really happy to have this partnership with AsInt. I think it works very well, specifically because we, as both companies, we were able to provide all this information and all this process under the same technology stack, leveraging for sure our business technology platform, where all the topics around asset master data integration, transactional data like maintenance orders or notifications, and other integration principles are fully integrated in the same technology stack to facilitate the life of the daily user. Okay, and with this, thank you once again, AsInt team, to invite me to this very interesting webinar.
Thank you so much, Tiago. I think you were able to summarize very well on our capabilities combined together. So let me just talk a little bit more about what AsInt brings to this space. We at the core are a technology company and we are an SAP partner. Our focus is on empowering our customers on their digital transformation journey. So we are known for our expertise in mechanical integrity, safety, and reliability solutions. And that means it includes products like IntelliSuite, the mobile application, risk-based inspection, asset inspection, CMLs for thickness monitoring, and the latest one is maintenance spend planning, or MSP. Our founders, Rohan Patel, Jared Reeves, and Michael Warren, they have a background of over 30 years in delivering asset integrity software across various industry verticals. And now they have put together a dedicated team that is leveraging their technical expertise to curate and to implement industry-leading and custom-oriented features. So, like Paul previously talked about, giving an example of the case study that he shared of a major oil and gas company, our primary focus always remains on understanding the customer's needs during the process design phase. So this is actually what helps us to tailor the solutions in a way so they can perfectly align with all your specific requirements and objectives. Over to you, Tanmay.
Thanks, Sonali. Thanks, Paul. All right, so just want to chime in on a couple of things. So what we do here with like AsInt and SAP is there's a few advantages and challenges we are solving that Paul and Tiago discussed. One of them is like having just a single source of truth, right? So when you see like a snippet of the tile equipment and like asset inspection, CMLs, all those tiles there. So with SAP, we are combining, just like Paul said, you can do all of your strategies in just one software application with one database that stores all of this data and more importantly, talk to each other, right? So that's one big advantage that we bring. And what that does is like a complete work process that both Paul and Tiago touched on. What that does is it doesn't just separate, like remove the data silos that are usually present on the execution part, but it also starts removing the knowledge silos. The way I define knowledge silos is like, let's say you have somebody working in the planner section for a long time in the on site, and you have somebody working as an RBA engineer for a long time, or a fixed equipment engineer for a long time. What happens is they have deep knowledge of their domain, but then they don't really understand the other person's perspective because there's a knowledge silo between the way they execute their work, right? So by having a full asset life cycle management in one single source of application, that what that does is it starts like removing the knowledge silos and people start talking to each other. I'll give you one example that a lot of you probably have faced in your careers. Like an RBI engineer or an asset integrity manager or an engineer created a task to do this inspection in 2024, right? Now, if you log into the system today, like some inspector just gets informed that, hey, this inspection is overdue, and the inspector has no idea why, because what happened is the task got created, the planner got the notification, but the notification just got closed because the planner probably didn't have enough context on the notification. And now you have an inspection that never got done, and then now it's showing overdue on the inspector's end, right? So what we do is we create that full asset workflow and tracking for everybody and everywhere, right? So for example, in the task, you have the task created, then now you can track the notification, now you can track the work order from that notification. And as a fixed equipment engineer, you will be able to show what's happening with the task that you suggested. Did the notification get created? Did it get planned? Did the work order get executed? So now you have the full visibility, and now the departments start talking to each other because you've closed the loop on the full execution front.
Thank you, Tanmay, and thank you to all the speakers for sharing your valuable insights so far. There were a lot of questions posted in the chat. And I can see regarding differences between the methodologies. If we can combine the recommendations and a lot of questions related to those. I'm sure my team was able to answer most of those. Just want to ensure that if it was not addressed during session, we will make it a point to get back to you on your question post this webinar via an email. So with that, we have come to an end to our session for today. And just want to thank all the attendees once again for taking out their time, for being so energetic throughout the entire session, and for your participation. I just want to let you all know that this is part of an ongoing series of webinars that we at AsInt have started. And we have just launched this to better understand the industry, to get a chance to interact with all of you, our experts and our industry leaders, and to just continuously improve our solutions by seeking out fresh ideas. So our previous webinar, just before this, was on achieving turnaround excellence with digital wall chart. If you missed that, you do not need to worry. You can find the entire recording on our YouTube channel. And I also encourage you to explore our LinkedIn page. So all the upcoming topics that you can see over here, we'll be posting the updates in that space as well. So we hope you found the session enriching and insightful. I'm sure we do. And thank you once again to the speakers as well for sharing your ideas and your expertise on this subject. Here's a quick QR code for those if you want a details demo. We look forward to connecting with you all, and thank you and stay safe.
Thank you, everyone.
Thank you, everybody.
Thank you, everyone.
Have a wonderful day.
Thanks for joining.
Thanks
Thank
for
you.
joining.
Bye-bye.